want to welcome Jonathan Gortat. Uh, Jonathan serves as Director of Licensing and Strategic Alliances at Stanford University's Office of Technology Licensing. I would say it's one of the most influential and emulated tech transfer programs in the world. Stanford has long been a powerhouse at turning faculty research into real world impact, and Jonathan plays a key role in making that possible. He has more than 15 years of experience in tech transfer, and he brings deep insight into how ideas move from the lab to the marketplace. I believe his work spans licensing strategy, pre seed investment, startup development, and building productive partnerships across academia and industry. Uh, I've invited Jonathan today because tech transfer is no longer something very peripheral. It's a very essential skill set for researchers like us trying to extend their work beyond publications into broader impact. So, whether you are exploring commercialization for the first time or thinking about how to build durable industry relationships, this conversation with Jonathan is about helping see tech transfer not just as a departure from scholarship, but also a bridge that can expand its reach. Jonathan, welcome.
Thank you. And I apologize. Let me know if my voice is not coming clearly. I woke up without a voice, so I've worked very hard to get that back in the last couple of hours here. Um, so I'll set the table and say that I'm going to start talking about the history at Stanford and technology transfer at Stanford, and then kind of dive down into types of intellectual property. And the following hour, I know David, my colleague from a law firm, will be talking mostly about patents. So I'll leave most of the patent conversation to David, but we'll talk today about copyright material, specifically a lot geared towards mHealth around software and data licensing. And then we'll kind of move to what that looks like in the tech transfer office when we're thinking about these types of questions, followed by some business models and a regulatory landscape for you all to think about at a high level. And then I'll conclude with a few individual case studies of technologies that have made it from, say, the research to the marketplace. So this year happens to be the 55th anniversary of Stanford's Tech Transfer Office. And just so you can get a snapshot, last year we received 541 invention disclosures from our researchers. So that's about 1.5 per day if you don't include weekends, or if you include the weekends. If you don't include the weekends, it's about 2 per day. And that resulted in, you'll see 114 different types of licenses signed in the last fiscal year for us, leading to about $70 million in revenue back to the inventors and the institution as a whole. As I said, this is our 55th year anniversary, and so I put here a couple of the technologies that have turned into companies, or many companies in some cases, over the years that have come from Stanford Technologies. I think everyone is familiar with Google. Actually, an interesting little side bit, the licensing manager who did the Google license and met the founders of Google when they were grad students here at Stanford, he actually retired about 3 weeks ago. He was on my team. So he stayed in the office quite a long time, as you can guess. A couple other ones to highlight here are FM sound synthesis. So anytime your cell phone rings, that's actually a technology from Stanford in there that was licensed to Yamaha in the early 70s. And then, of course, the boom of the biotech industry, recombinant DNA and functional antibodies. And one true thing throughout the years has been OTL's mission and strategy. And that's really to promote the transfer of technology for society's use and benefit, while generating some income back to support research and education at the institution. That said, not all technologies generate a lot of income. Some are huge societal impact, which is just as important. And I would encourage you all to talk to your institution's tech transfer office, and I think you'd find a similar mission for them as well. At the end of the day, it really comes down to main tenets of how we think about things on a daily basis in OTL. We do what's best for the technology, we plant lots of seeds, And we try to be as flexible and reasonable as possible within the confines when we're working with our licensing partners to get the technology out to the marketplace, given restrictions that could be in place. So from here, I'm going to dive into specific types of IP. And I broadly put this into a bunch of different buckets. And you'll notice there's one highlighted in the red at the end that I'll touch on briefly. First and foremost is patents. I'll say design patents and plan patents are something you're probably not going to encounter, but they are out there, so I wanted to put them out there as options. Design patents, you could think of those mostly used a lot of times in automobiles, right? They're ornamental in nature, doesn't provide a feature or a benefit to something useful for the technology. It's just ornamental in nature. Plant patents protect plants. And then utility patents are the thing we're most familiar about, and that's what the focus of the next lecture will be on. But I want to talk a little bit about utility patents when you're writing them with your patent counsel and your tech transfer office. From the frame point of the frame of reference of a researcher, you can think of the specification in the patent as basically the full research paper. So it's going to include the background methods, the detailed description, examples showing how the invention works. It helps basically help someone who's reading it understand and be able to replicate the innovation. When we think about the other main part of a patent application, they're the claims. They're akin to the conclusion section that have bullet points that define exactly what you're laying out legal rights to. So the claim structure is very formal, and it's the legal boundaries of your invention. And this is basically what you're excluding others from doing without your permission. If you want to think of it very briefly, the specification is how it works, and the claims are what you legally own. And only the claims define your enforceable patent rights. And we'll talk about inventorship and things like that in the next hour, I believe. So I'm not going to touch too much on patents today because we didn't want to be duplicative in nature. A lot of the talk today will be around different types of copyright, protection of ideas. This could cover data sets, processing pipelines, model weights. Unpublished model weights could be know-how as well. There could be hyperparameters that you're thinking about in your models that you're working on. Lots of different things. Trademarks, I think everybody knows examples of trademarks, Coca-Cola and Nike. Basically, they're a name or a symbol that identifies a source or a service or a product and have some inherent value in the name or the mark itself. We don't talk about trade secrets too much in an academic setting because we're in an open research environment, so everybody wants to publish their findings for the benefit of society, and I think that's a common thread throughout most universities. But sometimes there are, we call it know-how, which is unpublished information that might be essential to understanding how technology works or critical to the function of that technology that maybe doesn't need to be in a manuscript because it doesn't add any technical details that you need to publish the manuscript. And then data and different models, those are really subclasses of know-how and copyright. And those are going to be developed over time when you're working on your technologies. I do want to highlight two important things. One, there is another type of intellectual property that's available in the EU only, which is a database right. So this allows folks a limited term of protection, 15 years, from the first time that a database is published. And it's a little open in terms of, what that 15-year window is. It's basically from the first time your database was published or used in a service, and the database took substantial resources to create or build in the marketplace. So that's something unique to the EU. We don't have that here in the US, though I could see it happening at some point in the future, but right now it doesn't exist. And for patents in general, we need to know about any potential public disclosure before you're going to disclose it. So if there is patentable subject matter, we can protect the invention ahead of that public disclosure. Public disclosures can be a lot of different things. It could be a thesis defense. It could be a poster presentation. It could be a department presentation that's maybe open to the public. Obviously, a manuscript being published would be a public disclosure. And now things are moving earlier, and there's lots of journals that are publishing things, preprints and things like that earlier and earlier. So I'd encourage you all to talk to your tech transfer office well in advance of any type of public disclosure so that you can protect anything that would be patentable. When you disclose an innovation to your tech transfer office, typically you'll see something like this cycle of innovation where it starts at the, let's say, 1 to 2 o'clock position where there's an invention disclosure. It'll then get assessed in the tech transfer office, and these bullet points here on the left side start to think about what are we thinking about when we're assessing the technology. Is this patentable? Is this copyrightable? Is there any tangible materials here that we could license? If it is patentable, would the patent be enforceable? We start thinking about the market size. And then here at Stanford specifically, we always ask the inventors, is this something you want to do a startup in? So we can start having those conversations early and often to kind of frame the path of the technology and the path that you wish to take for a startup company. And then from there, we go on to the protection of intellectual property and marketing. So we're down to the 5 o'clock position, if you will, on the clock, where we'll reach out to companies to identify, hey, does this meet a need in your market? Or also just to get feedback on the technology that's valuable to you as faculty members of, you know what, we talked to 5 people in industry and they all said if you could do X, Y, and Z, this would be a valuable technology for them. Right now, it's not ready for prime time. And that's entirely possible. And then as we move over to the 8 o'clock time, we talk about licensing, and we'll set the terms based on comparables that we have from previous licenses that we've done in a similar area or databases that we have access to kind of assess what's reasonable in the marketplace. It all goes back to that being flexible and reasonable that I talked about in those early slides. And then from there, commercialization, hopefully royalties and research. So this is a beautiful cycle of innovation. However, in reality, the cycle of innovation looks something much more like this. The disclosure will come in to the office in the bottom left, and then we will assess the technology for three main principles. What kind of protection is needed? How commercially viable is this? And what type of investment is it going to need to get from where it's at now to a point where it's licensable or commercial ready? And so within that, we'll be talking through different strategies with you as the inventors and also outside parties, kind of assessing what to do along the way. So it could move into that commercialization bucket right away. And maybe when we're in the commercialization bucket doing some diligence, we realize, well, we need to do these 2 key experiments. And so we give that feedback to you as the faculty member, and then it comes out the bottom, and then you go and do some more work in your lab, and it can come up through again, and then it's maybe ready to be licensed to an industry partner. Another thing that's very common here at Stanford and many other institutions is we'll go out and market those technologies. And a lot of times the outcome from that marketing effort isn't necessarily a license, but the company is interested. Boy, I'm really interested in that area of research. I wonder if we could turn this into a sponsored research project in the laboratory or across multiple laboratories. And that's what this strategic alliance indicates. So those strategic alliances at Stanford, we view those as long-term partnerships where there's going to be a company doing research in one or multiple labs, and they could have other things that go along with that as well. There could be fellowships where there's students being funded through that strategic alliance. There could be a clinical trial that takes place at the same time because maybe a company has a certain asset that they need a clinical partner for, but they also need to do some more fundamental research to understand what's going on. And so there's just many ways that we can deliver the fruits of all the important work that you as faculty members do to society. And you'll notice some of these arrows are coming off. They don't really seem to come from anywhere. And that's because a lot of this could just be published and there's no protection needed. But the benefit to the public is through that publication and understanding and really advancing the state of the art in terms of treatment, in terms of how society benefits from looking at the work that you all do on a regular basis. So this is a more accurate, albeit cartoonish representation of what happens in terms of inside the cycle of innovation, inside of a tech transfer office. And it's particularly cartoonish because there's no direct connections, right? each technology can take on its own path in this cycle. So now I want to shift gears to talk about copyrightable material, specifically in view of data and software. And the first thing I want to talk about is the fair use doctrine. And the fair use is a legal rule that lets people use small parts of copyrighted work, maybe text, it could be images, it could be videos, without permission for things like teaching, research, commentary. I think they even allow parodies, as long as it doesn't harm the original creator's market. Now, there are 4 pillars of the fair use doctrine to think about. The first factor is the purpose and character of the use. The second factor is the nature of the copyrighted work. The third factor is the amount or the substantiality of how much you used of that work. And the fourth factor is the effect of the use on the potential market for or the value of the work itself. Now, there's currently lots of pending court cases that could lead to lots of changes in the coming months and years. One of the most recent ones from maybe a year and a half ago now was the Goldsmith case, where the court basically narrowed the standard, finding that a use where you add some new expression, some new meaning, or a message alone is not sufficient to satisfy that first fair use character, which is the purpose and character of the use. Now, I will say, I had to update my slides because I had my initial slides done. And then the Copyright Office came out with an update on what to do with copyright and artificial intelligence on May 10th. So I quickly read through the 130-page guidance document put out by the Copyright Office, and I'm still digesting it, quite honestly. But I did want to give you some high-level thoughts from my read of the initial document. So from my view, this new report signals there's going to be a tightening around fair use for large-scale AI training. They have a conclusion in there that says, when copyrighted expressive works are copied to build commercial-grade models, especially where licensing avenues already exist, the first and fourth fair use factors. So the first factor is the purpose and character of the work, and the fourth one is the effect of the use on the potential value of the work, are probably going to be against fair use, because what you're practicing can substitute for or dilute or displace the market for the originals that were out there. They did go on to say that and recognize academic efforts, and said that purely analytical or non-commercial research uses that don't allow that underlying material to reemerge in a different output are likely to remain fair use, which is a really important carve out for universities. They do warn that once that research model or the accompanying data set that could be there migrates to something that's a commercial deployment, there's going to be a little shift in how fair use is viewed, and it's going to be a much less favorable fair use analysis. They don't recommend some type of compulsory licensing in their guidance document. They do urge Congress to basically say, let's let the voluntary licensing market mature, and that licensed training sets and revenue sharing deals are already coming out, like in the Goldsmith case, and music, photography, Hollywood images and things like that, nil imaging, or nil licensing, excuse me, which kind of shifts the burden to Congress to decide, what do we want to do with this? But from the Tech Transfer Office, I'm starting to look at this, to look at your data that you're using to create your models and your data sets. I really need to understand that provenance a lot more. I really want to understand the sources of that, the permissions, if there's any opportunity for, perhaps there's human data, were there any opt-out flags in there? Second, I would definitely want to start thinking about ways to isolate or keep separate research-only data sets and models headed towards commercialization. I really want to think about ways I can have licensing terms that have contingencies built into them, into licenses, into sponsored research agreements that really take into account where the data is coming from. And okay, I'm using this set for research, And then I'm going to have a completely separate data set that I'm going to use for my commercial model. And this is going to lead to increased speculation and scrutinization from sponsors and folks who are looking to acquire AI assets. They're going to really want a clean bill of health on those copyright data sets. And we'll have to price the deals accordingly based on, the knowledge of the market and what we know of the data. So this is really a shifting risk calculus. I think this is the early days still, and it's a very interesting time to be in tech transfer, specifically around AI. And we'll see, if there's training on copyrighted works, how the licensing structure will be, or if there's going to be, some more robust fair use opinions coming out in the coming time. But I really want to start thinking about, from my side as a tech transfer office, and you all, if you're going to start a business, how to start building a contractual or a compliance framework into the technology now. That's a lot more than I intended to talk about fair use, but I thought it was really important given that recent guidance update on May 10th. So I think a lot of you are aware, but I just want to bring up the point that having a very small, specialized training set can be just as valuable, if not more valuable, than something that's trained on, a larger general purpose model. We've seen several instances of that here at Stanford, where a smaller model trained on very domain-specific data outperforms those large general purpose models. From the tech transfer office side of the house, I went through some of those questions that I'm going to ask about provenance, and I'll have a checklist here in a little bit that you can kind of go through. But I really want to answer 3 questions. Is the data that you're giving me, is this scalable? Is this efficient? And is it private? And when I talk about scalability, synthetic data generators can create enough data to stand in for millions of individuals very quickly. And I think there's lots of good ways to use synthetic data to train models and validate models. Once, in terms of efficiency, once the data is, or the model is trained, I want to look at the different models that are available there to create a bunch of different records in a matter of minutes, as opposed to hours or days that you would need before, or even years collecting the actual data. And then for synthetic data, another advantage of that is around privacy. So synthetic data doesn't contain any real personal information, and it has privacy protections along the development pipeline that are already built in. When we think about software licenses, and specifically open source licenses, I want to highlight a couple things. One is, once you open source something, choose to open source, which is fine. We do this all the time, and it's a viable commercial path. You can't unopen source it. So you need to make sure that you select the appropriate software license or open source license for the technology that you have at hand. And you'll see I have a variety of licenses listed here, open source, proprietary, source available, and I'll just highlight some key features. So the ones that are italicized, which are in the first, say, 3 rows, those licenses include an explicit patent grant. What that means is that when someone shares their software under that type of license, you're also giving users of that software permission to use any of the patents that cover how that software works. So that's a key differentiating factor between those types of italicized licenses versus the ones that are not italicized. This protects anybody from using your technology from patent infringement. So they're able to use that software because you picked that license that allows them to use any underlying patent to enable that software. The most common licenses we'll typically recommend are the MIT or BSD licenses for folks to use, which still have minimal restrictions around them. They allow modification, redistribution, and commercial use. And there's also ways to do a dual licensing approach. So sometimes you can release certain software for non-commercial use, and then have some terms in there that would say, if you need commercial use, you need to come get a commercial license to build this into your product. So I'm not going to go through each one of these software licenses in detail, but I just wanted you to be aware there's a wide variety of options for software licenses that are available for open source. Same goes for data licenses. There is a multitude of data licenses out there, and I'll go through these in a little more detail because I think this is something that's a little newer and growing in terms of the amount of data that's being used on a regular basis. So the Creative Commons license is great, and there's many different flavors. Much like you go to the ice cream shop, you can pick a different flavor depending on what you need. And in fact, they have a great website that if you answer some simple questions and tell them what you're trying to do, they will recommend the most appropriate type of Creative Commons license based on the information that you've given them. So the Creative Commons 0, the CC0, has no restrictions whatsoever. It's completely open. It waives copyright rights. It waives database rights. People don't have to say that, give you attribution for using that model. So Smithsonian is the biggest one. Their open access is on a Creative Commons 0. That's the biggest one I could think of. Typically, I would say the one I recommend the most is here in row 4, which is the CC BY NC 4.0. This is a non-commercial permission, so you're allowing anybody who's using this for non-commercial purposes to use your model and adapt the model, as long as they give you credit saying, hey, my underlying model was CC BY 4.0, and here's where it was developed. Please take this and build on this. However, there's no commercial rights granted along. One other model that I will talk about here comes in that last category, the proprietary custom data license, and that's the PhysioNet model. PhysioNet 1.5 is a license that allows for free use, redistribution, modification of data sets for research and education, as long as you're crediting the source and the drive works are similarly shared, so there's share-alike principles included in there, which makes a lot of sense. It also prohibits commercial use without a separate permission, and it is tailored specifically to the biomedical research community. So it's a bit more restrictive than some of the Creative Commons licenses, which permit commercial use, but it's most similar to the third category here, the CC BY SA. But it's specifically designed for folks who have medical data in the community, where there's norms like reproducibility, data provenance, taking those things into consideration. So that's one that's becoming more and more common among the data community. And if you just type in PhysioNet 1.5 in Google or your favorite search engine, doesn't have to be Google, you'll see the credentialed healthcare data license that comes up. I went too fast. There we go. So I wanted to highlight the difference between software licenses and data licenses. So software licenses are built on functional rights that allow you to run or modify or redistribute code in a certain way. The data licenses are more about remixing and how you're going to use really content that might not have copyright protection available, and is going to depend more on the contract terms and the ethical norms of the data than the legal mandates. So that's really the distinction between software and data licenses. Now, I will tell you that when one of my licensing associates or I go to meet with a faculty member and talk about where their data and where their software is coming from, this list of questions will come up every time, because we really need to understand where the data and the data rights come from. Are there any restrictions on the data use? For example, oh, I got this data as part of an NIH consortium. The NIH has this license applied to it, and you can use the data for further processing, or you can't use the data for further processing. You need to understand all those implications. Or maybe there's sponsored funding from a nonprofit organization that has different restrictions applied to it. So we really need to understand that. Use of personal data, we want to make sure that complies with the applicable privacy laws where the funding came from. So privacy laws, we'll talk about that in a few slides, but Basically, country, state, all matter when we're looking at privacy laws, and there's differences to each entity and each legal boundary of a state versus a country versus a different continent. We really want to understand the data and make sure that you're getting to the desired stratification, not introducing artificial biases with the data set that you're collecting. And I think that's critical as we look at, especially smaller indications, orphan indications. Are we getting a desired stratification to predict what we're looking for in a certain disease state? Then I also want to understand whether the model is going to be static or dynamic, meaning, do I need to update this data constantly? Is there going to be some upkeep cost to keep retraining the model and improving the model? Or is it a model that, once it exists, it's fine and ready to go, and I don't need to touch it ever again? And then last, want to look at any additional IP or license rights that apply based on sponsored funding sources and where your data is coming from. And this is, I'm not going to go through this slide. There's a lot of information here, but I really wanted you all to have kind of a readiness checklist when I'm thinking about the different types of data that I'm collecting. And so you'll see there's 8 different categories I think about here. And I'm just going to cover the categories really. The provenance or the source of the data. Who owns the data? What do I need to do to clear the rights to get access to that data? Does this contain personal or sensitive data? Does this contain confidential data that's separate from personal or sensitive data? What are the regulatory compliance issues I'm going to face here? What are the legal issues I'm going to face here? Are there permissions or restrictions on the data? What do those header files say? What does the documentation look like? What does the metadata say? I have seen cases where a faculty member will disclose an invention, and there's, they've incorporated code from, say, 200 to 300 different open source licenses. Well, we need to go through and verify each of those open source licenses to understand the restrictions that are there. And I can tell you, if there's one section in the header that says all this is granted under an Apache 2.0 license, that's an explicit patent grant. So it's going to be very tough to file a patent on something where you're giving an explicit patent grant. And second, everybody can take that and use it and run with it. So it's going to be very hard to protect data that comes after if you've included something that has, copyleft, strong copyleft language in one of those open source licenses. And then, as you think about moving your technologies outside of the university to a commercial setting, you want to start thinking about what kind of ongoing monitoring you want to do. You need to audit where your data comes from. How often do you need to do that? Update those terms of service. So those are other things to think about when we're thinking about data licensing. So that's kind of a background on data licensing, software licensing, and what we're thinking about in the tech transfer office when we talk with you all about your inventions. These are some of the checklists that we go through in our head. And as you move and potentially are entrepreneurs and taking your own ideas and starting great companies with them, things you should think about as well. So I'm going to move on from here to talk about strategy and commercialization. And I want to say, first of all, there's an inherent lower bar for diligence to publishing a paper than there is to getting a product into the marketplace. And that diligence related to basic research will affect how downstream licensing, and there's an increased need, and demonstrate that there's an increased need for diligence before licensing intellectual property. Sometimes with data heavy inventions, there's a lack of really formal IP protection around patents, or a lack of ability to keep anything trade secret in an academic environment because we want to publish, and that's great. We love when faculty publish papers. That's the lifeblood of the university. It increases our difficulty, though, in terms of licensing what we can license out to industry. So the tech transfer office is really looking to understand where the value lies in the technology that you've disclosed and the temporal aspects of that value, right? So it could be very valuable now, but in 6 months, if someone has to rewrite the whole code base, there's a very limited amount of value that could be described for that technology, or at least ascribing the value towards that amount of time that would be required to recreate where you are today into a more proprietary form. I think everybody can understand why mHealth is so important, but I just wanted to put a couple high-level bullet points here. The market is enormous and growing, expected to reach 268 billion in the next 9 years, which is a threefold increase from where it is today. There's about 350,000 healthcare apps out there, and the fastest growing segments, there's two of them. They're mental health and chronic disease. And then last is a need in low and middle income countries. There's a 70% mental health treatment gap in those low LMICs. So there's a huge opportunity to move technologies from the lab to the patient population that needs it. I'm not going to talk about this too much because the previous speaker, I caught the remarks, talked really a little bit about how faculty innovation maps and the cycle of going through ideation to company creation and venture funding and how to think about that. What I wanted to, the only thing I'll point out here is I think of them typically in three buckets. There's the technical buckets, there's the funding buckets, and the IP buckets. And all these things can move around in here based on a specific set of circumstances, but it's really important to keep in mind that just because you think it goes in one place, it could actually fit in another place as well along your product journey. So I'm not going to cut too much on that because the previous speaker covered that really well. I wanted to talk a little bit about regulatory and privacy concerns when we're thinking about mHealth applications. So software is a medical device that's SAMD. The FDA has different tiers of them, class 2, 510K is an example of one. And it's really critical for market access in the US. And then there is the equivalent in the EU, which is the MDR Rule 11, and they have a similar classification system, 3 tiers. The main difference between the EU MDR Rule 11 and the SAMD tiers lies in the classification systems and the level of detail they provide. So the EU system uses a risk-based classification system that's more about the purpose and the impact of the software on patient health, whereas the FDA system focuses on the potential for harm to the patient. So those are the key differences, but things you need to consider when you're looking at regulatory path. And then I have here listed HIPAA, GDPR, and CIPRA. CIPRA is unique to California, but your home states might have their own individual privacy concerns as well. So I think all of us know that HIPAA protects the privacy and security of the individual with their personally identifying information, their PHI. GDPR is the standard in Europe, which protects the personal data of citizens, regardless of where it's processed. It doesn't have to be PHI, it's just GDPR in general. And then the more local guidance, for instance, CPRA, the California Consumer Privacy Rights Act, protects the personal information of California residents. So I put that in there because you all are located around the country and you may have different regulations based on your state. You also need to consider that when you're sharing data between a faculty colleague in California and one in Kansas, that there may be some different data compliance terms that we need to incorporate into a material transfer agreement, for instance, or a data use agreement, for instance, based on the individual requirements of that municipality. So just something to keep in mind. The scope of HIPAA is limited to health, and GDPR and CIPRA are a broader range of personal data. So that's something to keep in mind as well. I did put in here the FDA Secure Product Lifecycle Guidance, which is the FDA's work with the IT community in ensuring cybersecurity of medical devices. So, we're not getting hacked medical devices and people are able to take control over a person's medical device, which would be pretty extreme. And I have this bottom note here in caution about evidence and reimbursement, and I really want to watch for scope creep. So a lot of times when you're in a company and you're working on a product, or you're in your lab and you're working on a product, you think, boy, wouldn't it be great to add this feature and that feature in addition to what we've already done? And likely scientifically and from a research perspective, it's very interesting to add that on. But if you're already going down a regulatory path, that could take it from one class of device to another class of device. So you really need to think about, what am I doing here? And is my scope creeping too much that I'm going to go on to the next category device that might have some additional hurdles, or it could invalidate the work I've done so far, laying down that regulatory framework to move the technology forward. So I just wanted to put that there as a word of caution. There was a question at the end of the last session about different business models. So I was glad that question came up, because I did want to cover a different set of business models that are common, and I will go row by row here. So the direct-to-consumer subscription model, typically you're seeing $5 to $15 of average revenue per user per month, and these are things that you typically find in app stores, maybe an in-app purchase, where consumers are paying a monthly fee or maybe an annual fee for access to different health apps. It could be mood tracking, sleep fitness, mindfulness. I put some examples here. Headspace, as you know, is for mindfulness and meditation. Flow is menstrual cycle tracking and wellness, and the Noom is for weight loss and behavior change. The strengths of these direct-to-consumer models are they're very scalable. There's not a lot of friction to get to the market, and they tend to be good for, I would say, behaviorally driven products. However, there are some challenges. They go through a high churn rate. The customer acquisition cost is very sensitive. So, it's very tight window where you can acquire a customer. And the last thing is, it requires a strong user experience and user interface and value proposition for it to be useful. The second row here is the prescription digital therapeutics category. And these are just the 5 that I thought of when I was preparing for the presentation. But the typical revenue there is $600 to $900 a year per patient, typically paid by the insurer or by Medicare. The channel which it's found is the physician has some kind of they'll prescribe through the physician, and there's some kind of formal regulatory approval process that's involved with there. There could be a CE mark or an FDA regulated software that's prescribed by doctors to treat a condition. It's often reimbursed like a drug. Some of the strengths of these type of models are they're a high revenue per patient. The payer support is possible so long as you have good clinical evidence showing strong clinical impact. On the downside, these types of business models often have a lot of very costly clinical trials, regulatory hurdles, and sales cycles to work through. So I put a couple examples here that you can research on your own time, but Reset by Paratherapeutics is used for opioid use disorder. Endeavor RX is an ADHD treatment via kind of gamified treatment for ADHD. And Somrist is an insomnia treatment. The next category is B2B to B2C. I know that's a mouthful, but basically this is a model where you're getting $2 to $5 per member per month, and these are types of apps that are sold to HR or benefits leads at an organization. So you probably have some of these at your universities where HR is offering you access to this app, and it's delivered to the employees. The employers are paying for access to these wellness platforms to improve workforce health or productivity, whatever the case may be. There's a lot of different types out there. These are scalable because they're typically done using benefit brokers, and there's not usually a lot of regulatory concern or regulatory burden around these. So you can access these models without a lot of regulatory hurdles. However, you have to show return on investment based on productivity or absenteeism. And then there's long sales cycles associated with this when you're thinking about that. And then a couple examples in there are the mental health app Ginger, or I think it's also called Headspace, if I remember correctly. Vitra Health, which works on reversing type 2 diabetes. And then Kaya Health, which is a musculoskeletal pain management app, working around ergonomics and things and how to have mobility when you're in your office a lot more. The fourth one I would say is software development kit licensing. And these typically have a fixed annual fee plus a revenue share. And these are platforms that you're going to integrate into some third party's platform or an app, and basically where you as the company or the university as the licensor, we're providing some AI tools or some kind of symptom checker to work with the API or the toolkit, or we're embedding into their apps or their digital experiences. These are typically a lot of IP licensing, and they're pretty high margin, and they're good for B2B scale and software as a service alignment. On the downside, not the downside, but let's say a challenge that is required here, you have to have ongoing API performance and maintenance, and really need to understand where your data is coming from, what the IP landscape is like. And I put a couple examples in here as well. I notice I've been talking for a while, so I'm going to move on to the next one. The last category I can think of are grant-funded deployments. So things like the Gates Foundation or USAID, where we're doing bundled volume license. And typically you'd work with those Gates Foundation, Ministries of Health, international NGOs, where you're deploying tools in low and middle income countries via huge volume deals backed by donors or the grants. These are great programs because they have high reach, strong social impact, and there's a lot of partnerships in the ecosystem that you can identify along the way. As you can guess, there's some challenges as funding cycles are very uncertain for these types of business models, and it may not scale well unless you have those subsidies available. So I'm going to continue on. Now I'm going to give you 3 case studies of technologies in the mHealth space to kind of wrap up before we do questions, just so you can get a flavor of different types of cases that we've seen throughout the years. The first one is Invenza Kids. So this is a nonprofit that was spun out of Stanford Medicine as a 501c3 program, so that cost is not a barrier to hospitals who want to use this suite of AR, VR tools for really distracting children while they're in the hospital for a prolonged period of time. All the core operations are philanthropically funded. In-kind hardware and cash gifts come from tech donors. Meta, Magic Leap are a couple of the ones that have donated. It's a 2-tier partner model. So everything is free at the point of care. And now there's over 100 hospitals that are using this technology. They receive the software, the implementation playbooks, and staff coaching on how to use this technology. And then there's also partners in under-resourced settings that get the same package, plus donated headsets. They have on-call tech support built in, all at no cost. The consortium, the IK consortium, the Invenza Kids consortium, pools the data and open sources new VR apps created by members along the way to keep improving the app and providing a higher quality VR environment for kids that are going through treatment at various institutions. So the money flow in this one is really a charity, right? The product for the company at this point is a better patient experience. So there's no licensing or subscription fees. Instead, it relies on individual donations, corporate gifts, philanthropic gifts, and some research contracts from time to time. Um, and they also have some grant writers, and they sell small. They actually have a shop online where you can go buy some branded items to diversify kind of where those income streams are coming from. The lives touched here is this, and this has really impacted tens of thousands, if not hundreds of thousands of young folks worldwide who are working with these devices in daily clinical use. Um, so it's a great story and a very different business model than something that's traditionally seen.